Hello, everybody. Thank you all for coming. I hope you're not too tired from the day already, because I'm going to be talking quite a bit. Yeah, let's get started. A little bit about me before we start. I'm Kinnera. I am an Android developer at ioki in Frankfurt at the moment. If you want to find me tomorrow or later today, I'm probably near the dessert table or sneaking a gummy or something. You'll see me. Then, okay, just the agenda of what we're going to talk about today. But before we do, just a little thing. I'm super into 3D printing at the moment, so I have a little Android. And I have a little question in the middle, so stay tuned for that. All right, so the agenda. Before we talk about journeying through white labeling, let's talk about what it actually means. And then once we know that, we'll talk about what aspects to consider, what differentiates a white label app from the core app that has pretty much all of the functionality that you need, how to white label, how we can streamline this process. And then once we know that, we'll know how to make a white label, right? And then we'll talk about how to construct it, and then where to put all of those white label files. And once we have that set, where to put that set into the greater scheme of things, the architecture of it all. And then we'll talk about how to release a single white label app, and how to refine the process when this number and complexity of every app increases. So first, what does white labeling mean? But again, before I tell you what white labeling is, I would like to talk about why specifically for ioki we need white labeling. I think it'll help explain how this process works, and for whichever use case you would like to try it for, you might understand how it works better. So we customize on-demand mobility solutions. So we complement existing public transport with something demand responsive, which means equipping our customers with the platform to provide these services, which is consulting, mobility intelligence, autonomous services, most importantly, white label apps. But creating an app for every single client is rather time-consuming and a rather repetitive process. They all want an on-demand solution. We know this. They all want an app. They want a backend API that goes with it. They want a pricing system that's specific to them. They want their own colors on it. They want their own strings. They want their own little images. They want the regional language of whichever country they're in. They want their areas and shuttles customized to a mobility solution. They want payment options. They want, at the core, they want to customize an on-demand solution that we do have. So as this demand increases, the number of apps increases, and the number of features increases, and of course, code increases. So with an increasing number of features and code, we need to separate responsibility between the core feature-driven app that we have, that's the source of truth, and also the white label projects, while optimizing for the scalability that we need. So what is white labeling? There are two basic things that are a part of white labeling. First, rebranding. Colors, strings, languages, map locations in our case, stations, local transport providers, all of the things that rebrand what this means to that particular region or customer. The second thing is feature customization. Now, feature customization means messaging APIs when they want to do something different, payment APIs, features like ride series if they want their customer to book a series of rides, or if they want their customers to be able to pay in the car, things like that. And this is the only animation I have in the presentation, so I'm going to do it again. It says rebranding and then feature customization. Okay, so how do we white label an app now? There are two things, like I said, rebranding and feature customization. So we'll trade up soon enough, but let's start with rebranding, which is comparatively straightforward. So first thing we have is localization. What does this mean? We want the customer to have the language that they have in their particular region. The idea here is to override. That's usually the solution. So if your code refers to the feature name resource string, like in this example, and the device is set to English, we know that Android loads the string from the first one, the strings file, the main file that it has. If the device is set to German, the second one, and French, the third one, right? I hope that's right, because I just translated that from my high school French, which is not much at all. The recommendation is to not hard-code any strings. So this is good for example purposes, but what Android recommends you do is declare all of your strings in a main resources file, and then you extract it, translate it, and then integrate it back into the app which sounds nice when you have one language, 2 languages, 3, 4 maybe, but when you have 10, not really fun to translate all of them and then integrate them back into the app. So what do we actually need for localization? Our requirements are that we not just language override, but also app overriding. So for example, we have 2 German customers. One wants to say continue instead of next, which happens all the time, by the way. We want to make sure that they have this option. So we need both source set overriding and app overriding. So for this, we use a translation management solution called Localize. So as fun as it is to declare all of your strings as resources in a default file and then do all of the extracting, translating, and integrating, this allows us to eliminate localization for developers. So the ownership shifts to the UI UX team. So they own this, and then we localize the product in parallel with the development cycle. So we speed up publishing with over-the-air updates. These translations, and then again, it is the same. We download these translations and then upload them to our CI/CD workflow. But this is now automated. We don't need to do this by ourselves. So how we specify the locale will come to a bit later. All right, so we have one code base, and we work on a single app as we go along. So we have to change the UI experience for each user. We override all of our things, which we will come to now. First thing we override, colors. So I thought it might be cool to try an Android maker's Paris app. So I asked our white label designer to help me out, which is our usual process. They receive their assets from the customer, and then they provide us an asset package, and then we go to work. First, colors. I don't want to say simple, but this is the prettiest part of the process. I can point out the splash background and splash branding, for example. We override whatever is necessary. And they're absolutely lovely colors, both of those. I really like them. But it gets more interesting than overriding. We also go ahead and do this for drawables. So we have a wide set of drawables that we contain default resources for. But then we also have splash icons, notification icons, onboarding logos, you name it. They're a possibility, not a requirement. So we do provide a default thing that customers can use. The same thing goes for strings. Lots of non-mandatory options. With resources, the most important thing to remember is that you need a default set of resources to fall back on, right? So when an app tries to run a white label, but you haven't provided text-specific resources, then it doesn't know what to do. So it does need a default. So that's one thing that we have to remember. So as we go ahead, this is the end of our UI experience. This is what our Play Store screenshots would look like for the Android makers by droidcon Paris. So absolutely beautiful. I love the colors. But we haven't gotten to the functionality yet. This is the more interesting part. Now, necessary secrets. Well, not secrets, you know, like kind of secrets. We want to specify a locale for the localization that we discussed earlier. The same way that we overrode string resources for the app. But this is not really an infallible process. These are just 2 resources. But what happens when we have so many of them, right? Wasn't the best idea to override, as it turns out. With overriding, there's no really good way to make sure that you have all of the values that you need, like definitely need. So we start to offer way more options, as the ... indicates. But it's really hard to keep track of what is optional and what is necessary. So before we go ahead and I tell you the solution that we found, what do you think is the secret to Android development? Don't say this, because this doesn't count. Yeah, what do you think is the secret to Android development? Anybody? Yes? No? I mean, there's no right answer. You can have a different answer than the one we have. No? OK. Sorry?
It's open source. So
open source? Oh, nice. Yes, but not our answer. Our answer is interfaces. Sealed classes, interfaces. We use them way more than necessary, but they're really good. So sealed or otherwise, in case of sealed, for example, it becomes a restricted class hierarchy, right? And the Kotlin compiler ensures exhaustiveness, which is what we need. So what did we do with it? We created an interface called technical configurations with all of these non-secret secrets and the secret secrets. So it has the locale, the configuration we need, things like app links, and this is now part of the API surface, right? So it's hiding all of the internal implementations in the white label apps. It knows nothing about what each white label app has. We're leveraging this evaluation over the interface without leaking any of the implementations. Now, so we go from this unending list of string overrides to something different, right? We override what was in this interface, sealed interface, and then we give it, this is so much cleaner, right? I thought about adding an FR, which is more in theme, but my major skill is just reading menus, and minor skill is eavesdropping, which is not really helpful, so English it is. Yeah, now, so we're done with rebranding. We have all the pretty colors, we have the secrets, we have all of our strings, all of that. So what do we do next? We know that customers don't want every single feature, right? So for the most part, we use backend feature flags, which we just use an if-then statement. We say, backend use feature A, let's use it, and otherwise nothing. So we offer a bunch of solutions, things like I mentioned before, ride series. They want customers to book a series over a couple of days, or they want to offer customers 3 different rides and then ask them to choose which then they want. So all of these are options that not everybody wants. So we use backend flags for the most part. But what if it's a feature that needs permission before the app is loaded, or before the backend data is loaded, or a tracking permission that we need, for example? We can't really get that from the backend. So what do? More interfaces. We have something called a white label feature in a sealed interface, and then we add all of our features into it. So when we talk about features here, we have a set that we include, and then we check this set when we're toggling the feature itself. So all of these things, we have our features now, we have our technical configurations, we add it all into another interface called app configuration. And this has a primary locale, a technical configuration keys, and with this base interface defined and a sealed interface for technical configurations, we restrict this hierarchy as much as possible. And this way, we've dotted all our I's and crossed all our T's for every single white label app. Now, this is great. We have a feature that's absolutely wonderful, but the client does not want it. So what do we do then? If it's just client changes, it's all right. We use these backend flags, and we use the set that I just talked about. But what if it has an external SDK that the clients do not need? Once they decompile the app, they know that they have resources or an SDK that they absolutely don't need. And it's hard to explain that. So we want to find a way that we can have optional dependencies. And this is my absolute favorite feature, so let me talk about it. We've split up every single optional library that we had before. So earlier we had all of our dependencies for all of our apps in every single app. Again, not something that's sustainable. So we went ahead and split it up into 3 libraries. We'll call them lib feature, lib default implementation, and opt-in implementation. Now, think of lib feature as like a tiny little kitten now, instead of like an overfed cat, which is worse before. So in lib feature, we include only a minimal set of classes that allow us to differentiate between the feature implementation types and the interface that is implemented by the actual libraries that give you these fragments, because our interface says we need a new instance of a fragment. So now we have this interface. We need the glue code that decides where to find this code, because this is only an interface, but we need to find the implementation. So what is the glue code? The glue code is the code that finds out which implementation to use. So we have a top-level function here called fragment factory, and we use service locator. So usually when you talk about interfaces, we use reflection in Kotlin, right? We say this interface is finding its implementation in the same place, and it's instantiating it. But here we're using something called service locator, which is really interesting because, as the name suggests, it creates and keeps an instance of this class in a central registry. So think of this as something like Dagger, for example, but all of your components here are application scope. So nothing scope defined per se, but just available throughout the application. So that's what the service locator does. It creates an instance of this particular class without finding out where it is. Now, how does it do this? We need a specific file located in this metadata services. The file is the fully qualified name, and then we give it the fully qualified name of the implementation class. So this is the service locator pattern, and it'll check this service meta file, instantiate this name class, and then this factory can be used to create the fragment later. So where is the implementation class? We've talked about the interface, we've talked about how it finds the implementation, but what about the actual implementation? Here we inherit a feature fragment factory, which we created earlier in our lib feature. And then we have this as a fallback for customers. For example, if someone doesn't want a feature, we have a no-op implementation, which is a non-operational implementation, which we'll have in our default. And in opt-in, we'll go ahead with a lot more code and complexity, but with the same interface. So this way, we can have more than one implementation if we have multiple SDKs, for example, when we talk about tracking, analytics, things like that. Okay, so with this chosen pattern, we can have lots of marketing libraries, analytic libraries, and this is without polluting the core of our app with third-party implementations, right? So in this case, for example, we say if our partner name is the conference, we'll add the implementation to this specific flavor. We'll say, for this implementation, we'll add in the lib opt-in implementation dependency. So this is how it works. Now, we know how to white label an app. We know what it means. We've done rebranding, feature customization. We know exactly what to do to create a white label app. So let's talk architecture. What is inside a white label first? As we talked about, we have our resources folder, which has all of our values, which is our strings, colors, drawables, all of those things that we absolutely need. And then we have our app config file. This is where the magic happens. Because I've talked so much about interfaces. We implement this interface here. And then we give it all of the information that it absolutely needs. And this brings us full circle from our rebranding and feature customization discussion. So where are all these apps, really? Because we have so many of them. Right now, I think last I checked today morning, we had like 70 of them. So where are they? We have a project, as it usually goes. And then inside of this project, I'd like to start with 2021, which is when we had a rather simpler implementation, but it wasn't as useful. So we had one composite Gradle project with Gradle modules, right? Modules are just all of these features and domain things that we had. And then we had a lib white label, which is a library whose dependency we used in app to provide all of these features. Like all of these resources and app config, we had it in lib white label. Now, we'll talk about why there's an issue with this. The problem is that this white label app, once we have it outside as a dependency to the main app, is coupled to the rest of the source code. So we can't really provide a new white label with the same source code as the other white label because it's so tightly coupled together. Other feature modules could unintentionally use this as a dependency, right? It has a built-time performance decrease, and it's an architecture nightmare. So when we release a hotfix, for example, we have to publish a whole new white label app. We don't really want to do this. And in terms of teams, since we had two separate teams, one that did the white labeling and one that actually worked on the app, it was really hard to separate responsibility. And again, we can't really create those optional dependencies that we talked about. So what did we do next? We said, let's reverse this dependency between the app and the library white label. So it was outside, and then we moved it into the core app, and we moved all of the library modules outside. We said we want this app to be a dependency, all of these libraries and modules to be a dependency, not the white labeling itself. So what should be in the app Gradle module is just what is related to the white labeling process. So we exchanged them. Now this is 100%, all these modules down there that you can see 1 and 2 are completely independent of the main app itself. This is the goal that we want. It's decoupled now. We can create a white label without without the library really seeing where it's being used. It's just a library, right? It provides an implementation and that's it. And we can now easily set responsibilities. So if we have a team member that's working on a particular module, they can have ownership of that module. So this way, I will talk about how we can exclude dependencies now, which is, like I said, optional dependency is really interesting because we went through a little bit of time trying to figure out what we can do. So in late 2022, we took off into an idea. We can do better than just having the libraries outside. We have two independent Gradle projects. We have ioki, which is the white label app specific thing, and we have our library, which is our Gradle project containing all of the libraries that we need. We separated it into feature and library, and feature is what has all of the scope code. So it has help, registration, things like that. They cannot depend on each other. And all of the libraries can depend on each other, and the features can have a dependency on library. So they're independent. I'll tell you why. Because Gradle defines independent Gradle modules as something that has a settings.gradle file. And it's a mark of a Gradle that this is a standalone project. So this tells us that they're two very separate projects. I'll tell you why this is really interesting. They share some tooling code, but not really. In the future, we want to make them completely independent, but for now, it works as we need it to. The main point to start entry is inside the library. We have a core library that has the starting point. So why does this matter? I mean, I'm telling you we're moving things around, but why is it really useful? It doesn't really help, right? So it's prettier, cleaner, better. I mean, if it doesn't convince you, there is a nicer reason. We're moving things around because they're kind of wrong. I mean, we talk of them as wrong, but why are they really wrong? It's because something called resource merging. What is resource merging? Think of all of the resources that we have in our app. From every source set or library, if they're unique, they just go into the final app directly. That's easy enough to do. If two or more matching versions of the same resource, then only one version goes into the app, right? This is where priority comes into the picture. So first build variant, which is, for example, the conference plus debug. That goes above both conference and debug, which is debug will be the build type, and then we will talk about the conference. So the way that we provide these resources to our apps define which resource gets used. So the next slide is a question. So whoever gives me the first answer gets my little Android. It's not fully functional, so I can't promise you it will hold your phone, but if you have double-sided tape, it will work perfectly fine. All right, so if we have resource merging for a conference release build, which resource do you think will be used? Yes. We have release builds, debug resources, we have main resources, we have library resources. So we have a little priority order here. Anybody? Yes? D? Yes, that's right. That's first, the test release build exists, but we don't need it for our app, yeah? And then we have the ioki release build, but that's not the release that we actually want because it doesn't check anything other than, it checks AMDC debug, it doesn't exist. It checks AMDC release, which also doesn't exist. Then it checks for debug and release, which also do not exist. Then it checks for AMDC, which also does not exist. And then it goes to the main source set. If we do not have the main source set, it'll go ahead and look at the library. Why is this interesting? What if there are more than one library? Then what happens is that it looks at the library that is topmost in our dependency list. So, like I said, our white label shouldn't be a dependency. Why? Because in this case, the order matters. We have to add our flavor-specific resources before anything else. So every time we added a dependency to any of our libraries before. So if you see the little flowchart there, our lib white label is outside. So we needed to add it to every single library whenever we needed to use it. And we always had to add it at the top of our dependencies list. Not really something that you want to remember every time you create a new module, right? So what happens now? Our white label is completely inside. We never need to provide a dependency itself. So whenever we use a different library, we just use the library dependency. We don't really care about which order of resources we're providing. Now, code owners. This is something that we've started using recently, and it's been great. Here we can specify which teams or developers are in charge of certain types of code, right? In this, file order is important. So first we say our library, which is our core app, all of our modules and resources where we have our features, our libraries, our domain, all of this is in charge of the code. The core team is in charge of this. And then we say the ioki, which is our white label apps, will go into the project implementation team. So in this case, whenever a PR is opened inside of this module or inside of this directory, the specific developer teams are automatically requested for review. So in this case, we don't really need to worry about whether we're stepping on somebody's toes because they will have a notification that tells them to take a look. Okay, so now we have our white labels, we know how to white label it, all of the architecture, we've moved things around so it looks pretty and nicer and way easier for developers to use, so how do we release these? Before, what we used to do was we had maybe 10 apps in 2021. We said we'd build each flavor, we'll upload it to the Play Store, and then we'll roll them out one by one, which was fine when we had a couple of apps, but it got complicated very fast. We have localize somewhere in there. Localize, while building, it downloads the specific locale that we gave in app configuration, and then it downloads it, and then uploads it, and then bundles it together with the flavor, and then uploads to the Play Store and rolls it out. And this is fine somewhat, but it took up to 2-3 hours once we started increasing our number of apps. Not really fun when something fails and the whole thing has to be done all over again. So we're crossing our fingers on Slack. There are like 20 cross-finger emojis from everybody on the PO team just so they make sure that it's released on Friday, so we don't have to go into Monday doing it. So not really fun. So how do we release now? Like I mentioned, these sub-projects are independent, right? So we thought, why not move them further apart? The reason we're building this is that this common library Gradle project is common to every single white label app build. So how do we improve this? We said, let's go ahead and push all of these to Nexus. So we have our own Nexus repository. We have a little Gradle task that pushes each of these libraries to Nexus. So every sprint, we also do a library release before we do a white label app release. And if there are any hot fixes, we can just publish a new version of the library. We don't need to worry about what kind of white label we're bothering with whatever hot fix that we're doing. So this app can later consume the library that on the Nexus server and then make faster builds or releases. How do we do this? So first, the app project includes library as a normal dependency, and then we make consumption of this library optional. It only happens when we have this Gradle false set to true, right? So we say if the Gradle property exists, then we'll replace all of the local dependencies with our Nexus dependencies. And then we use these published libraries in settings.gradle, right? We say we give all of our Nexus credentials and then set it up as a Maven repo for our build. So this way we replace them even if we're maybe checking a white label locally. We say we're testing it, for example. So now we have a really nice structure because we've separated them into features and libraries. We have a really nice nested thing going on. It's more aesthetic, to be honest. We saw it on, we were talking about it in one of our discussions, and we thought, oh, that'd be nice to look at. So we also have a lot of more nesting inside of features. For example, we have ride creation, so we have nesting inside ride creation, things like that. So at the moment, we have 70 apps in sequence in one little workflow, but we want to split them. So we have a library that's published to our Nexus, and then we use this library to bundle into every single build flavor that we do. So all of these can be now run parallelly. And on our CI/CD workflow, we now run them in parallel. And something that ran for 2 to 3 hours now is less than half an hour, which is really good because we don't really need to worry about publishing every single white label either. If there's something we want to fix in one single white label, then we just publish that particular white label. We don't really need to worry about anything else. And that publishes in 10 minutes. So win-win, right? So in the future, what do we want to do? We already have build cache enabled, but little issues because we have so many modules and things still depending on each other. We recently, last week actually, enabled configuration cache, which improved our configuration build from, I think, about 30 seconds to 4 or 5, which is really fast. Obviously, the build itself takes time, but the configuration is faster than it was before. We also want to do more parallel white label builds, which means that we can bring down half an hour to maybe 10 minutes if we ran all of them in parallel, and maybe picking and choosing which ones we want to release. So we're constantly evolving our processes to overcome problems that we face and then improving as we go along. If you have any ideas about white label apps or you do them yourself, please come and speak to me. Always happy to hear ideas. And that is the end of my presentation. Thank you. I hope you liked it. And any questions? Yes.